Residuals and residual analysis. Okay, so if you get some data, which I've used from a previous question, and you go to Calc Regression Linear Reg, now what we're doing differently here is we're going to take the residual and get it to just calculate it for us and put it into list 3, as you can see. So we say copy residual to list 3. And there's our usual thing about the equation of the line and our r squared. Now remember, r tells you about how close the dots are to the line. So if you get an r of 1 or -1, then the dots are exactly on the line. And so that's the equation of the line right there. And then that's the predicted values. So that's a prediction line. And these are the actual dots, and they have a distance from that prediction line. And so you can see some are going up and some are coming down. Now, if you go to graphs and you go to a scatter plot and you want list 1 versus list 3, because list 3 is our residual, you get this graph. And this is exactly the same graph as we did before. We just tilted the line. So if I just compare it, so this line, which before was at an angle, is now this horizontal line along here. So you can see like these distances are actually these distances too, and these lengths of these lines are what we call the residuals. Now, if you're above the line, you've got a positive residual, and if you're below the line, you've got a negative residual. So again, positive and negative. So they're pretty much the same graph, except that angled line is now flat, and so this is what we call a residual plot. Okay, and what you're trying to look for here, and this is very important, so no clear pattern means linear. Now remember, we're doing a whole bunch of linear algebra, and we're assuming with R and all the other things we're calculating that we've actually got a line, but if there's a clear pattern, then you haven't got it. You can't be using linear algebra. So what is a clear pattern? There's only 2 clear patterns you have to look for. Frowny face, if the dots look like they're sort of closer to that frowny face, or smiley face. So if the dots look like they're closer to those than they do to that straight line, then you've got to assume it's nonlinear and do a transform, which is the next video. And you can even see it on these ones as well, exactly the same thing, whether they fit the frowny face or smiley face as well. There is a little calculation-y thing. This is from the formula sheet, which says if you want to calculate residual value, actual value minus predicted value, you don't have to put this in your notes because it's actually in the formula sheet. It's one of the very rare things you need in the formula sheet, but just in case, you can put an example in there. Okay, so this is from last year's exam, and they want you to determine the residual, and they give you pressure at 9 AM is 1013 hectopascals, and you've got to round that answer to the nearest whole number. All right, so you got to look at, this is your prediction line, which is given with your prediction equation, and we've got the pressure at 9 AM is 1013. So you put that into your calculator like so, and you pop out that answer, and so it looks like the number is just 1012. So if we use the formula, remember, which is actual minus predicted, so the actual was 1013, and we subtract the predicted 1012, that gets us a whopping 1 hectopascals. And you could have seen that just right from the graph, because remember, this graph is also the prediction line, so that's 1013 there. And if you read it up across, it pretty much is 1012, and you can see the difference is 1. And that's how you answer that question. Okay, so we've got a residual plot down below here with the least squares line. I'm guessing that's the line they're referring to. It's not that obviously clear. And it's about the assumption you make between atmospheric pressure at 3 PM and atmospheric pressure at 9 AM. What is the assumption? The assumption is it is linear. So assuming assumption is linear data. Okay, now if you look at the graph, you can actually see quite clearly there's a smiley face, and so it says here the residual plot above does not support this assumption. Explain why. You don't say because there's a smiley face. Don't sound like some sort of weirdo, like, oh, I saw a cloud, it looked like a puppy. No, we've got to say the data shows a clear pattern and therefore is non-linear. All right, so they just want to say that you can see there's a clear pattern, and that gets you the point.